Okay, hi guys. This is a video on the quadratic formula, and the quadratic formula is, well, it's this thing that you're seeing on the screen here. It's this big, messy formula. X equals negative b plus or minus this big square root of b squared minus 4ac over 2a. And the reason we have this formula is it's another way of solving a quadratic equation. We have been working in class a lot on factoring, and factoring is a great strategy to solve for x when you have a quadratic. So we've been working with things like equations like I have y equals x squared plus 2x minus 7. And we know that that's a quadratic equation. It's got the x squared in it. And we know if we graphed it, it would make the shape of a parabola. And a lot of times we want to know, well, where does that parabola have roots? Where's the x-intercept on the graph? And so to figure that out, one way we can solve is we can set the whole thing equal to 0. 0 equals x squared plus 2x minus 7. And we can solve for x. And that's a great idea. And sometimes the best strategy to doing that is to factor it into two parentheses and set that equal to 0. And so we've been using some strategies in class. We've been using things like the rectangle diamond approach to figure that out. And that would be kind of our method. But sometimes factoring doesn't work. Some problems are not factorable. And if that's the case, we need a backup plan. How else can we solve this equation if we can't factor? Or what's another way we can do it? And another way, another backup plan to that is this fun formula, the quadratic formula. So this is just another option to factoring. If you can't factor, it's another option to solving for x. So like I said, it's a backup plan. And you might write that in your notes. Just another way. If you cannot factor, this will always work to solve for x. And we're going to try one together. Let's try a different one. Let's try this problem right here. So let's say you wanted to solve this equation. X squared plus 8x minus 20 equals 0. Okay, well, we're going to solve using the quadratic formula. In this problem, a, b, and c are the numbers in front of the variables here. They're the coefficients. A is right here. In this case, a is equal to 1. B is 8. And c is negative 20. So knowing those three values, I'm ready to use my formula. And the way I'm going to do this in class is I'm going to organize my work. I'm going to have two answers, typically. One for adding in the formula and one for subtracting. So I'm going to organize my work into a t-chart. And the reason I'm going to have these two answers is because in the formula that we wrote down earlier, it's this, negative b plus or minus the square root of b squared minus 4ac. So plus or minus means I need to solve it two times, once for plus and once for minus. And what I'm going to do is I'm going to try and show my process as best I can here. I'm going to write x equals negative b plus the square root of b squared minus 4ac all over 2a. That'll be on this side. And then over here I'm going to write x equals negative b minus the square root of b squared minus 4ac all over 2a. And then I'm going to go through each one of these, substituting in a equals 1, b equals 8, and c equals negative 20 into both of these equations. Why don't we just do one side first and kind of go through that a little bit. So let's put in x equals negative b, so I'm going to turn that into a blank parenthesis, negative parenthesis plus square root b squared, so parenthesis squared, minus 4ac, 4 parenthesis parenthesis, all divided by 2a, so 2 parentheses. And then I'm just going to go in and basically plug in those values. A in this case was 1, b was 8, and c was negative 20. So if it's negative b, it's going to be negative 8, plus b squared, so 8 squared, minus 4a, so 4 times 1, times c, which is negative 20. All over 2 times a, so 2 times 1. Perfect. Everything's substituted in. Now I got to clean up this mess, and I'm going to go slowly. So x is equal to negative 8, so negative 8, plus this big square root. Let's slowly go through our steps here. 8 squared is 64. 8 times 8 is 64. Minus 4 times 1 times negative 20. So 4 times 1 is 4. 4 times 20 is 20, 40, 60, 80. So that's 80. And I have a minus times a negative. So I have a negative times a negative is a positive, 80, plus 80. All over 2 times 1 is 2. All right. Then I keep on going. X is equal to negative 8 plus the square root of 64 plus 80. And then we're going to square root that. So 64 plus 80, and then square root that. So 64 plus 80 is 144. And we're going to square root 144. Why don't we just write that down? 144 all over 2. Sometimes these square roots are going to come out to nice even answers. Like this is a great example of one that's going to be a good answer. And sometimes they are not. So we can do the square root of 144 in our heads. But in case you're using your calculator, be sure you're very careful to use the right operations. In my case, this calculator, the version I'm using, has a square root button right here. So square root 144, I can just type that in. Your calculator might be a little bit different. But the square root of 144 is 12. 12 times 12 is 144. So I have negative 8 plus 12 all over 2. And at this point, my square root symbol is gone. It's no longer in my problem because I did the operation. I square rooted 144 and I got 12. So that symbol is totally gone and I just have negative 8 plus 12 over 2. And negative 8 plus 12, that's easy math now. That's 4 over 2. And 4 divided by 2 is 2. X is equal to 2. Which means this graph has a x-intercept at x equals 2. There's one of my answers. Now I got to repeat this process again. But now I'm going to do it up here for negative b minus the square root. So now it's x equals negative parenthesis minus square root b squared, so parenthesis squared, minus 4 parenthesis parenthesis, a times c, all over 2 times a, 2 parenthesis. And it's the same problem. I'm going to substitute in b. b was 8. I'm going to do b squared is 8 squared, minus 4ac, 4 times 1, times negative 20, all over 2 times 1. Thankfully, most of the math is going to be the same. Everything over here is going to kind of match up. So what I'm going to do is I'm going to kind of shortcut this a little bit and say, you know what? I can go all the way down to this step right here. It's going to be the same thing. It's going to be x equals negative 8. There's going to be a square root of 144 all over 2. The only difference is instead of this plus square root 144, it's going to be a minus square root 144. That's really the only difference in the math. So now we know the square root of 144 is 12. So now I have x equals negative 8 minus 12 over 2. There's my big difference. And negative 8 minus 12 over 2, that's negative 20 over 2. And 20 divided by 2 is 10. So x equals a negative 10. And now I have my two values for x, 2 and negative 10, with the quadratic formula. I probably could have factored this one with a rectangle diamond and got the same answers, but like I said, some of these are not factorable and your rectangle diamond will not work, and this is your backup plan. Use the quadratic formula. It will work every single time. And what this means is that these two values, how it relates back to our problem, is yeah, that's the answer for x, but also if I was to graph this equation on the graph at, just make a little graph up here, at x equals 2, 1, 2, and way out here in negative 10 somewhere are my x-intercepts, my roots of my parabola. So I don't know exactly what my parabola looks like. I'm not doing a full-on graph here. I'm just really sketching this briefly. But I do know that I have an x-intercept at 2 and 0 here, and I do know I have an x-intercept at negative 10 and 0. And the parabola itself, I don't know, it probably goes down and then up. I don't know how far down to go yet. I haven't found the vertex, but I do know where the roots are. So kind of a helpful thing. really got to kind of memorize the quadratic formula. You just kind of commit it to memory, and then you can use it whenever you want. So it's a nice backup plan. If you don't want to factor, it works really, really well. All right, I hope that helps. Look for more videos on this. I'm going to make a series that you can kind of go through and practice and make sure you really get it down.